E to the x over 2 minus e to the negative x over 2.
E to the x over 2 minus e to the minus x over 2. Good. So that's the derivative. So the next thing here is to set this. Well, let me just take a look here. What is it actually looking for? So extrema. All right. So you would set this equal to 0. And the problem is that it does not equal 0 anywhere. Let me just confirm that graphically, because I don't know why they're giving this to you if it doesn't equal 0. E to the x minus x over 2. Oh, I'm sorry. I guess there is one place. So you can multiply everything by 2 to get down to this. Then it's like, where does e to the x equal e to the minus x? So in terms of like your critical points, or where you like want to try, generally things like 0, 1, maybe -1 are good places. So e to the 0 is 1, e to the minus 0 is 1. So it's kind of like you're not really solving it. You're just kind of using your I don't know, you're like you're kind of using just your intuition here to solve this. So but this is 1, this is 1. So that's a critical point, I guess. You can also see this graphically as well. So it says to confirm graphically. So if you graph the original, you get a graph that kind of looks like this. So you know there's a horizontal tangent there at 0.
Okay.
The next thing are the inflection points. You do the same thing with the inflection points by taking the yet another derivative. So let me grab this. Oh, nothing going easy here. Okay. Let me grab this. All right, so f prime of x is this. So f double prime of x is e to the x over 2 plus e to the minus x over 2. And this does not equal 0. And it's supported by the graph, the fact that, see how it's concave up everywhere?
Yeah.
All right. Any other questions, thoughts on that before we move to a new problem?
Nope.
All right, so let's do 75. That's kind of more of your classic exam question. So I mentioned this before, just the whole idea, like to be comfortable taking the derivative, you have to recognize that this is a product. F is 2 minus x, g is e to the x. Will you take the derivative of both of those for us, please?
F is just 1. And then
-1.
oh, right, yeah. And then e to the x is e to the x.
So the derivative here, f prime of x, is 2 minus x. So it's just taking this f times g prime times e to the x minus e to the x. So the -1 times e to the x becomes this. And since we do want to set this equal to 0, we're going to simplify, or in this case, factor out an e to the x. So you have 2 minus x minus 1. And you set both of these equal to 0. You set 1 minus x equal to 0. The 2 minus the 1 becomes 1. So you get x equals 1 as your critical point.
Okay.
So then for the inflection points, if they exist, you have to take yet another derivative. if you were going on to like calculus 2 or more, more advanced math, like you have to get really comfortable taking a lot of derivatives and recognizing patterns. Like the derivative of this right here is the whole thing because we've already done that part. But sometimes students don't, you don't see that because you're so, you just go back to, okay, it's product rule and you do the same thing again. But if you look back, the original 2 minus x e to the x, we already have the derivative of this. The derivative of the first one is everything you see there. So that comes from this first part minus the derivative of e to the x, which is e to the x. If you don't like that or it didn't make sense, you just go take your derivatives as usual. So this is 2 minus x e to the x minus 2 e to the x. Like that, you set it equal to 0. You factor out an e to the x. 2 minus x minus 2 equals 0. 2 minus 2 is 0. So you end up with this minus x equals 0 or x equals 0. And that's a possible inflection point.
Okay. Perfect.
So it is kind of like it's almost like that they're taking this, you're reviewing all this exponential stuff and you're just starting like at pre-calculus and going through the calculus. So you start with just properties and then derivatives and implicit derivatives and then extrema, which is what we're doing these few problems. And now we're going to integration. So like a problem like 91, we can look at. So integral e to the 5x times 5. We talked about this idea that you can integrate e to the u. The integral e to the u is e to the u plus c. Okay. So your u, generally these are u substitution problems. Your u is 5x. Your du is 5dx. And then you always solve for dx. So dx is du over 5. So this is the integral e to the u 5. So you always substitute in for u, whatever u is, and you always substitute in for dx, which becomes du over 5. And we talked about this idea that you really want to see some cancellations. You really want to see something go away. But mainly it's that the x's have to go away. There can't be any x's in your new integral. Now this one's nice because it does become that e to the u du, whose antiderivative is itself. And then you put the u back in. So this becomes e over 5x plus c.
Yep, that makes sense.
Good. And if you're ever stuck on a test, you can always take the derivative. You could take the derivative of what I have listed here. Let's say this was option A. You could take its derivative and you would get that answer there. All right. So we have let's look at I don't know, we'll do 92 next. So again, u is typically the exponent. So du is, well, why don't you give me the derivative here?
Negative 4x to the third.
Dx. Okay, so then you solve for dx. So dx is du over minus 4x cubed. So this becomes the integral e to the u minus 4x cubed. That's still there. It's du over minus 4x cubed, like that. And this time again, like there's a full cancellation. There's not always a full cancellation, but there could be. So it becomes this nice integral of e to the u du. Like that's the antiderivative is e to the u plus c. Don't forget that plus c, which is e to the minus x to the fourth plus c. All right, let's look at 94, and then I'll have you do 93 on your own. So 94 here, again, your u is always the exponent. Your u is, especially in these e problems. Help me out with the derivative here. What is the derivative of 1 minus 3x?
3.
Negative 3.
Negative 3.
Yeah, and that's really important. I just heard that a couple of times. Just really make sure you see that that sign goes with it. So it's integral e to the u. Now this time, it's the u over negative 3. There's nothing to cancel with it. That's okay. It just becomes like a fraction. So this time it's like, and I think it's good for new students to in calculus to bring it out each time that constant. And then it's just like all the other ones. The answer is it's e to the u plus c, but this time that negative 1/3. Right, so then you put that initial u back in, so it's negative 1/3 e to the 1 minus 3x plus c, and that is your Any questions on this before I have you try 93 on your own?
Yeah.
All right, so have you try 93 here.
Okay. 1/5 e to the 5x minus 3 plus c.
Got it. Good. Good. Really good. Okay. So let's look at 96. It's kind of different than the ones we've been doing. So the like we've talked at length, like u is your u substitution is always the thing in parentheses, but this, or I'm sorry, the exponent, but now it's the thing in parentheses. And so I don't really have any guidance for how you'd know. You just do a lot of problems and you see the patterns of this. But generally, you know, parentheses, exponents under a root, denominators, these are all possibilities for your u substitution. The other thing though is that your du needs to be in the integral. So in this time it is, it's du over e to the x. So it's integral e to the x u squared du over e to the x, and you get that nice cancellation. But this time it's not an e that's left over, it's it's just a u squared or power rule. Okay. So what is the antiderivative of u squared? What do you do with the exponent? Do you remember that?
Use u to the third over 3.
Yeah, 1/3 u cubed plus c. We'll put that u back in. So it becomes 1/3 e to the x plus 1 cubed plus c. All right, any questions on that before we go on like 109 grouping?
Me. Do we do 109?
Yep.
Or 111?
Yeah, all those are good. So I'll have you get a little bit more involved here. I want you to just without these limits, I want you to find the antiderivative of this, please.
Negative e to the u over 2 du.
All right, give me the final antiderivative. Like when you're all done.
Negative half e squared plus half.
Okay, so we're kind of far away. So your u should be minus 2x. Is that what you have?
Yeah.
So okay, so du is minus 2 dx. Dx is du over -2. So it's integral e to the u du over -2, like that. So it is -1/2 integral e to the u. So it just is -1/2 e to the u. And we normally do this plus c. but you don't do that in these problems. We'll talk about why in a moment. So this u becomes the minus 2x like that. So your answer is minus 1/2 e to the minus 2x. I heard something different.
Yeah, no, I made a mistake. That's fine.
Right. So the next thing here is you end up evaluating at the bound. So that's what's different about these problems here, is that you end up having to evaluate the top minus the bottom. Do you remember that from a previous lesson?
Yeah.
Okay, so it's like putting 1 in and then 0 in. So it's minus 1/2 e to the minus 2 times 1 minus 1/2 e to the minus 2 times 0. All right, so the first one is minus 1/2 e to the minus 2 plus 1/2 e to the 0. E to the 0 is 1. So it becomes minus 1/2 e to the minus 2 plus 1/2, because e to the 0 is 1. And then what you see a lot here, this is all just kind of rewrites, is you often see the positive one come first. You also see sometimes that 1/2 factored out. And then sometimes you even see it as the positive exponents only. So kind of, yeah, maybe more than you thought you're getting into with it, but there's quite a bit to do, to actually answer these. Your calculator can do these problems, but they don't do them exactly. Maybe the one you have will, I don't remember. But you can always like use the calculator, get the approximation, and then compare your answers to put these in the calculator and see if your approximation is the same. I would be very careful with that.
Okay. So that would just be our final answer like that.
Yeah, I mean, any of these four could be the final answer. They're all equivalent.
Okay.
All right, so let's see here. There's another way to do these problems, but I'm trying to keep it like the same as the way we've been doing it. So what I'd like to do here is have you just do this part.
Can I try to do the entire thing?
Sure. Yeah, absolutely. Absolutely. Yeah.
Okay. E to the fifth over 4 minus 1 over 4 e to the third.
Down here on the bottom.
Yep.
Yeah, that's good. That's really good. And there's a lot of other ways that that could be written. So just keep that in mind. But yeah, it looks good. That's really good. All right. Let me do 112, I guess. Yeah, let me do 112. So let me introduce kind of this other way to do the problem, and you can decide if you do or don't like it. So your u here is the exponent. X cubed divided by 2. Your du is 3 over 2 x squared dx. When you solve for dx, you multiply by the reciprocal here, so it's well, basically everything flips position. So the du is in the numerator. Anything that's in the top goes to the bottom. Anything at the bottom goes to the top. So it's 2 du 3x squared, like that. Everything just kind of flips positions. And then we haven't done this yet, but we're going to do this in this problem here. We're gonna change the bounds. So the whole point of this u substitution is that you actually are allowed to change the bounds, but you have to evaluate the bounds. So rather than integrating with respect to x, which you can see the x's cancel, we're going to integrate with respect to u like we've been doing, but we're not going to back substitute. We're not going to go back to, see how we went back to x. We can actually do the integral in terms of u. And that's the better way, but it's slightly more confusing. So to do that, you have to find u of -2, which means to put -2 in for x. That's -8 over 2, which is -4. And then 0 in for u, which is 0 cubed over 2, which is 0, like that. All right, and you can see that the x's cancel. That's the integral from -4 to 0. Bring that 2/3 out, e to the u du. So just take a look at that, and that's a 4 down there. Make sure you're comfortable with what I've done here, like see all the cancellations, because the idea is that it's a much more simple integral.
Okay. Yeah, that makes sense.
So the idea here is that, okay, when you find the antiderivative of e to the u, which is itself, you evaluate from -4 to 0. You don't have to put that x back in, and you end up getting the same answer. If you were to go back to x. So the idea is if you're comfortable with these change, it's called a change of the limits of integration. If you're comfortable doing that, I mean, maybe check your videos. I don't know if your teacher's doing that, but it will help
Okay.
potentially. So this is 2/3 e to the 0 minus 2/3 e to the -4, like that. So it's 2/3 minus 2/3, or 2 over 3 e to the 4th.
And then that's how the answer would look.
That's it, yeah.
Okay.
The we could I was gonna have you try like 111.
Okay.
But what I want you to try is like like what we did last time. So I'm looking for like, what is this in terms of du? Like what are the two limits? What goes here?
I got, so the upper would be 1 over E and the lower would be 1.
Your U, what is your U in this problem?
E to the negative x squared.
So it's just the exponent. It's just the
Oh, okay.
exponent. That's where the
Negative.
issue is.
Okay.
So then you still want to do the whole du, solve for du, but you can also put in 0 the upper and the lower bounds.
Okay, so I got negative 1 over 2E plus half.
Okay, so yeah, so negative 1/2 e to the u, and then, or did you already, you're talking about your final answer or your?
Yeah, the final.
Okay, so yeah, so what I was gonna have you do is just give me the integral here, but that's
Oh,
fine.
my bad.
Just because it. All right, so the antiderivative here, minus 1/2 e to the u, evaluated from 0 to -1. It's like you said here, it's minus 1/2 e to the -1 minus 1/2 e to the 0. This part becomes 1, these cancel out, so it ends up being 1/2 minus 1 over 2e, or e to the -1, depending on uh, let me see. So the next grouping, okay, it's around like logarithms.
Yep, that's
Okay.
fine.
All right, so I guess it's kind of the same deal. Like you're gonna see these introductory questions, and so this is the property here: log base 2 of 1 minus log base 2 of 8, and So log base 2 of 1 is always 0. Minus log base 2 of 2 to the third. So this 8 can be written as 2 to the third. The reason you choose 2 is because you want to match the base here. And then you can bring that 3 out in front. Why is it doing that? You can bring that 3 out in front. So it becomes minus 3 log base 2 of 2. Whenever the log base is the same as the thing you're taking the log of, it's always 1. That part is 1 times minus 3 equals minus 3 is your final answer.
Okay.
All right, let's try number 6. Actually, 5 was really a good question, but I don't know, 6 is kind of more the starter questions here. So the idea is like, if you don't have a calculator, can you write 81 as 3 to some power?
Three to the fourth.
Yes. Good. So it's really log base 3 of 3 to the fourth. Put the 4 in front. 4 times log base 3 of 3. This part is 1. 4 times 1 is 4. So where it gets more difficult is when you don't have, I don't know if we should do those. I'm debating whether we should do any of these. It didn't really even help with the calculus part. Okay, let's look at 21. A few more of these to close out today. Strangely, they're doing part A's and B's now all of a sudden. All right, log base 10 of 1,000. So a couple of things here. Let's just say it was a log of 1,000. If nothing is written, it's assumed to be 10. Okay, so it's log 10, 1,000 equals X. And just like before, you have to write 1,000 as 10 to some power. What would that be?
Uh, 10 to the third.
Yep, 10 to the third. You bring that 3 out in front. 3 times log base 10 of 10 equals X. That's 1, 3 times 1. So X equals 3. So the part B here, the challenge is again, like how do you write 0.1 or whatever you're taking the log of? You're taking the log of 0.1. Can you write that as 10 to some power? And when it's smaller than the base, it's always like, well, how do I do that? Well, 0.1 is really 1 over 10, and that's really 10 to the minus 1 power. So you kind of have negative exponents. We could do a quick brush up on review on that if needed. So this is log base 10 of 10 to the minus 1 equals X. You bring that minus 1 out in front, minus 1 times log base 10 of 10. And that becomes negative 1 times 1, which is negative 1 equals X, like that. All right, so this is probably as good a place as any to stop. We can make up some time tomorrow if we need. But that's probably a good place. If you have time, I would try a few more of these 22, 23, 24s, and then we'll move on to the calculus stuff tomorrow with this.
Okay.
Does that sound good?
Yep.
All right, well, thank you